My name is Gabor Wnuk. I'm the guy responsible for technical leadership of the mobile products in Grupa Wirtualna Polska. It's quite a big company, around 1,200 employees and 200 developers out there. And I want to underline this word products, as these are both iOS and Android native apps, as well as mobile progressive web apps. So it's a nice place to do experiments. And today I will talk about ReactNative from the native developer's point of view, as for the last 10 years, almost 7 years out there, I am actually an iOS developer. First of all, I want to explain two things. First of all, ReactNative is not some kind of silver bullet. It won't turn an app you've created during, let's say, this weekend into an Instagram and so on. In fact, I think you will discover the entirely new world of bugs and errors, because as you might imagine, ReactNative is another layer on your existing iOS and Android SDK. So yeah, you will have some fun out there. And to underline this major misconception about ReactNative, it is not PhoneGap. It is really true solution. I think 2 years ago, we've created one app using the PhoneGap, and in fact, it was the worst app we've ever created. I mean, app, because as you know, PhoneGap is just a web view inside your native container, and our users hated it. In fact, it would have been better if we haven't released it at all. So yeah, this is genuinely native. We have completely ignored, for example, Ionic, because it's like a modern approach on PhoneGap. And we've actually ignored native script because we are using React across all our services, web services. And our goal was not only to share the code base between iOS and Android, but as well across the web platform. So yeah, that was the reason. And just to TLDR for all of you, maybe some of you know this app. This is a gossip app we've created in Poland. Actually, it's the most popular gossip app. We took it for two simple reasons. First of all, it's a relatively easy app because it has around maybe 7-8 screens. And second of all, it's quite a big app, user base-wise, because it has around 500,000 active users now. So yeah, that was a nice place to start. And we wanted to approach it from the Brownfield point of view. So we have an existing app, and we don't want to rewrite the entire app from scratch and face the massive regression. We wanted to introduce ReactNative, check out the ReactNative, through implementing across following consecutive modules. So yeah, so what we were aiming for. So we took around 1 year of research looking for decent cross-platform solution. We were considering Xamarin, we were considering NativeScript, and finally we took our hit at ReactNative. We've discarded Xamarin only because we have no .NET developers in our company, and as I said, no NativeScript because we are using Angular, React in our company. So the most important aspect was to be able to utilize Brownfield and greenfield approach. Brownfield is when you have an existing app, you don't want to rewrite it from scratch. That's, for example, for what Facebook did, what Airbnb did, and Airbnb was like a blueprint for us. They had like completely identical case we've had. So yeah, we wanted to go with ReactNative step by step, not just rewrite the app from scratch. We wanted to increase our native developers' importance, and let's face it, creating a native app is quite expensive. You have to create, if you want to cover all major platforms, you have to create 2 apps. You have to pass both apps through your QA and maintain separate code bases across 2 separate platforms. And if you, for example, introduce something new, some new feature like a gallery in our case, the time needed to update your user base to your newest version of your app is quite significant. So what we did, for example, on this one of those first screens, I've shown you our one-page gallery, so-called. You can screen infinitely across all images in our article, and what we've done at first, we've created the web version of this component in React. We've introduced it in our web app, which has around 2 million users daily, and we were able to test it across few days. We were able to detect all bugs, get the user feedback, so maybe some buttons are just misplaced and so on, and then we were able to almost copy and paste the entire code base into our React Native app. So yeah, that was the big thing to achieve at the beginning even. Yeah. So we thought we will be able to write code by one developer across 3 platforms. I will go further on this later bit on, but yeah, that was one goal. And we are a public company, so we have shareholders. Shareholders love money, so yeah, everything we are doing to improve our performance and our expenses in a smart way. And last but not least, and it was actually, from my point of view, it was the most important part, because there is a lot of misconceptions about React Native, and actually on the JavaScript, in fact. So we wanted to convince our developers that JavaScript and this entire stack is a step forward for their careers. And to be honest, it didn't work out so well. So in our team, actually in my case also, my experience with JavaScript was like I've created some web page 4 years ago, and the JavaScript I've remembered is not something you can see now. So it was like jQuery prototype things, which are probably not used in any major projects now. But that was what I was remembering from that time. And how can you get to know what to use now? You can go on a few meetups like this one, of course, JavaScript one, or you can go to, for example, Stack Overflow. But there is a slight problem. Still, Angular JS and React JS are, well, not really popular. The biggest framework now in Stack Overflow is jQuery, which is not something you want to use now in modern project. So sadly, because the opportunities of React Native were so big, and it was something we wanted to introduce anyway. We wanted to, well, first of all, major software houses in Warsaw are switching to React Native, not because they want to switch to React Native, but clients are looking for React Native. If you are hearing that you can have your app twice in the same time for the half of your money, that's something you want to look for. And second of all, maybe currently, because the React Native is something new, the average salary for a React Native developer on a freelance project in Warsaw, but it's freelance, so it doesn't matter anyway, after taxes is around 10,000 euros. It's like twice the money you can get as a very good iOS or Android developer, and your client will be more than willing to pay that. You're creating the same app. Maybe you are the one guy who are creating 2 apps for the same amount of money. So yeah. And if this isn't too convincing even, we have few companies which have created their entire business models around React Native apps. So obviously Facebook, because Facebook is like a creator of React Native. But what was funny, even Skype, recent version of Skype was written entirely in React Native. So if you want to check how this looks like and how it works, you can just download the app. Yesterday we had a talk about the Skype case, and I've checked. They had like a lot of problems with stability, but it was mainly because they've created the app from scratch. So they had some ugly regressions. It wasn't the React Native's fault. Okay, so how does React Native really work? So there is no web view, there is no CSS and so on, there is no HTML, everything is really native. So everything you write in JavaScript is executed in so-called JSVM, which is, if you build your app as a release version, is attached to your binary. So yeah, it increases the size of your binary by around 3 megabytes, but yeah. So this is like a really rough overview of the architecture. So you have 3 parts: JSVM, which is on like a JavaScript. Okay, yeah. So you have JSVM, which is here. Bridge, which is responsible for serializing your all JavaScript calls from JS to native, is serialized to a form of a simple JSON. So yeah, you serialize your payload, and then you execute your all native methods on the native side. So the funny thing is, everything here is executed in background, and the only thing executed in main thread or in UI thread is executed on the native side. So then you update your UI, you collect your response, notify your JSVM, and so on. And again, you serialize the other way around, serialize your response and process your response on JSVM. So for example, this is a view from one of our libraries. You execute such a call. It's actually, this one is like a low-level call. You won't execute anything like this, but yeah. Then you have the bridge, and it's serialized into the form of simple JSON. You have the function name, method name, your parameters, and so on, and you execute the corresponding code on your native side. So everything you write in JavaScript have its native counterpart. I think the easiest way to understand React Native is that everything you write in JavaScript has its native counterpart, and the only reason you don't have to write anything in Objective-C or Swift or Kotlin or Java is because the community and Facebook did it already for you. So if you need it, you can do it. And to give you some simple proof, this is how you fetch something from an endpoint. You just fetch, then you serialize your response and process your response, and so on. You can also catch your exception. And if you open the Objective-C files, you will find that this is in fact an SURL session, and yeah, something you already know. And if you dig into the Java file, it's OK HTTP, so everything pretty familiar for you. And to prove it even further, to create such a component, you have to create on Objective-C, the iOS side, you have to create like 2 classes. Even if you don't need your UI components like UI view, UI and so on, you can create 1 class. But in our case, I've created 2 classes because I want to display like a simple label and to modify it in React Native. So I create this UI view, simply UI view, and so nothing fancy here, and something called a manager. So manager is registered in your React Native bridge. So it exposes all methods and the class name to your React Native bridge, and yeah, just expose your property, because as I've shown you here, we will be using this text property, this one label, yeah. And yeah, we have this property text, and if you want to modify it, we just have this property text. So we have this. This is a simple React Native component. So here we require our native component, which has exactly the same name as we had on the previous slide, and here we just have the simple render to show the component in our application. So to show you how this looks like if you compile your, this is an example iOS app. If you run it and you try to modify anything in ReactNative now, you just write it and you have the hot reload. And this is, in fact, our UI label. So yeah, with hot reload, it's like a 1 second reload. Okay, so how does it look like? We have this, our example app. This is, in fact, this is a weird slide. It doesn't show the, okay, so, but in a matter of fact, this is a proof, this is a UL label. You have the entire tree of your views here as well. So some people usually ask me, what are the limits of ReactNative? Is there something I can't do? For example, some low-level applications and so on. So this is something you can do at your home. This guy is, I want to call, he likes to call him professional American, so guns and flags and so on. So he created something like a robotic crossbow. His app is created in ReactNative. So he have an Arduino here, so he's communicating with the device through a Bluetooth. Again, I don't think he had to write anything because Bluetooth libraries are already available. So yeah, you can do something like this. Okay, so regarding Brownfield and greenfield approach, so when you just can't write your entire app from scratch, and in our case, it was the only case. So yeah, if you want to create your new app, so you just type ReactNative init project name, and actually that's it. So you have this standard project directory, project scheme, and directory tree. And there are two folders I want you to notice. This Android and iOS. So if you open each of them up, you have like a standard Android Studio and Xcode project. So you can simply open Xcode project in Xcode and just work on the project from the environment you know. But if you have an existing app, so first of all, you also write ReactNative init and so on, but you have to place your existing iOS and Android repo into corresponding directories, so iOS and Android. So second of all, you have to add your React dependencies, because you have to add actually React to your native app. So you add your dependencies to your pod file and build Gradle. So in case of pod file, it looks like this. So this is a standard pod file, a standard, well, very simple Ruby file. You add React core and some important basic components. You then run yarn install, pod install, so you install your dependencies, and that's it. And to give you a demo of our Brownfield example, so when you have like a part of app created in Objective-C and part of app created in ReactNative. So this list is an actually UI list view. So this view here is entirely native. But so just to show you, and if you have to control this up. So if you click on it, so this view is in fact this. Actually, this view is a list of those components. So each of those parts is like a separate component of this here. So this view is written in ReactNative, and this is in fact our gallery view, and as you might know, there are no images. So first of all, I want to add this image component. So this is a quite complex component. It has its own states. It has the preload features and so on. So if I, for example, modify this file here, you will see that the entire thing was hot reloaded, and it is state preserving hot reload. So if you are, for example, if you have an app which has like 5 views and you go across 5 of those views, if you are hot reloading an app in ReactNative, you are in the same place at the same every time. So you don't go back into the starting point of your app. You have the refresh here. And I want you to notice that everything I will do, everything this demo will show, is hot reloaded. So, for example, if I would have to, if I would want to add this component here in plain Objective-C, I would have to rebuild the app, and in case of Pudelek, it's around 4 minutes. But we have few apps which are building with a lots of flavors and so on, which are building around 20 and 40 minutes. So yeah, that's a big deal. So I will add here this component with the image. We'll save and hot reload. Voila. The entire component is visible here. Of course, a few things are still off here, so I will fix the labels and so on. So every time I'm doing, every time I'm doing some modification here, everything is reloaded. So yeah, that's a big deal for us because we currently don't have to build our apps every time we modify anything. So you can imagine, for example, a situation when you have your designer next to you and you just sit next to each other and he's telling you just move something a few pixels left, right, and so on. And yeah, currently you just see how this will look like. So yeah, let's scroll down a bit. Let's go, just to show to you that this is in fact state preserving. So I am in the middle of view, I am modifying styles for some components, and yeah, I'm still, well, somewhere next to the place I've been. So yeah, this arrow and the title. So yeah, so now it's actually almost correct. So let's change the font size. And yeah, it's, well, let's say it's okay. So, and if you dump your view hierarchy, you will just see that this is in fact lots of RCT view, which are extensions of your UI view class. So yeah, RCT image view, it is just UI image view you already know. So that's how it looks like. So the one thing we wanted to achieve was to be able to write code with one developer across 3 platforms, and actually it didn't work so well, but we were able to unify our business logic across all platforms. So all data models, all APIs and components which are completely independent from the UI. Currently we have like a 98% coverage of the same code base across iOS and Android, and across around 70% on the web. So yeah, it looks like this. So we have the shared part, which are data models, networking, and so on. And we have a separate presentation layer for all of our platforms. And we wanted to do this mainly because we didn't want to force our users to have the same UI and user experience across 3 platforms. If you're an Android user, you don't want to have iOS app on your device and the other way around. So that was something we did meaningfully. And to go even further, currently, if we have some like this gallery view, we have one component which is like a higher order component is above the presentation layer, and our presentation layer consists only of one method which is dedicated to each of the platforms. So yeah, we were able to achieve this 90% of shared code base across native platforms, and there's over 70% on the web. So yeah, shared knowledge and single language and better product quality. So currently we don't have to write our products 3 times. So we have like an iOS, Android, and web app, and currently we just have to write it once, check it on all the devices, but usually the business logic is pretty solid. You write your tests for the one like case, not for 3 platforms, and this test will be valid for all platforms. So before React Native, we've had like 12 iOS developers, 12 Android developers, and 12 web developers. So effectively, because we had to write everything 3 times, we had like 12 effective developers. So after React Native, of course, we have 24 React Native developers and 12 web developers, and usually they complement each other. So if something is too too connected to the native side, our native developers are not just solving the problem. And if something is let's not say simple, but can be developed by our web React developers, they also can take the same tasks we can. So the hot reloading. So this was like the biggest impact on our productivity. If you don't have to build your app in such a long time, so yeah, well, 20 minutes for one of our apps is absolutely something which holds our developer in the same place. And if you're working on an app, you have to build your app like maybe 10 times and so on. So you can just imagine how nice it was. And what was actually the most convincing for our native developers was you can still use the same quality patterns as before. In a matter of fact, I think native developers are the ones who might benefit the most from React Native, as you currently have the domain knowledge and the knowledge of the native platform of, for example, how Android system works, how the tasks are executed, and so on. And this is something that is far more complete than for let's say web developer who doesn't even care about what system actually does. So yeah, it's something which will be, I think, the biggest benefit for you if you want to consider any cross-platform solution. And yeah, just to give you an example of few quality patterns. So personally, I like to write my tests first. So that's how I, for example, build my architecture. It might be MVVM finally. Sometimes it's even Viper. So yeah, you can still write your tests the same way you're used to if you are using, for example, RSpec standard. So if you're a Ruby developer or Android developer or iOS developer using RSpec frameworks, you can still do this, and it's super easy. Okay. This was not done. And moving on, the one thing our developers didn't like was lack of typing. So currently you can use flow type, you can use TypeScript. It allows you to write your code in. Actually, it looks a lot better than the JavaScript I've known before this research. So yeah, you can write your code and use your typing and so on. And as I said, you still need your native developers. In fact, currently, because I am an iOS developer, that's why I am the leader of my team in this React Native case. So it is a lot easier for me to understand why, for example, something doesn't build on Xcode. That's, for example, yesterday there was a problem in React Native itself. They forgot to update some library and there were some compiler flags missing. So yeah, that was something I was able to solve, and I actually know the stuff. But you might imagine that it might be a bit harder for a JavaScript developer, web developer to solve. You can actually, well, if you are a web developer, you could Google it. But if you have the guy which has this knowledge in his head, so yeah, it will save you a lot of time. So as I said in one of my slides, time is money. So a few numbers for you after the research. So first of all, we have the revenue boost, and this number is in fact currently not correct. So first of all, there is a star, so it doesn't take into account that currently you need only half of your developers to do the same thing. You can use your developers for other tasks, more important tasks. So yeah, it doesn't take into considerations the salary And second of all, this number is correct for, I think, iOS, because on Android we've had few problems which were slowing our app down. So in Android, in fact, it may be around 110%. As I said, shared code base, and again, the star, because this is for iOS and Android. If you take our web app into considerations, it's around 70%, because web is a bit different than native environment. We are using crash-free users. It's a number we are using to describe how many of our users didn't have a single crash across the last week. So we are trying to move around 98%, and we are able to go up with the 1% point even further, mainly because Pudelek, this app I'm actually talking about, Pudelek is our first native app. It was created like 7 years ago, and it had very, very lame, very weak code base. So we are able to remove parts of our app which were were so well written, and we've replaced it with ReactNative. So currently we are going around 99%, let's say. Hot reloading, of course. So yeah, keeping your time and moving you with your productivity even further. So that was something really, really big. And what was quite surprising for us was how fast actually ReactNative was. So we weren't able to go below 60 FPS on Android. On iOS, the slowest device we've had was iPhone 4S. And it was still around 45 frames per second. So quite nice actually, even though this is a cross-platform solution. So yeah, that's it from me. If you have any questions, I'm here, of course, for you. We are here until tomorrow. So yeah, go ahead. Yeah.
Thanks for presentation. I have a pretty obvious question, power consumption.
In fact, it's pretty the same. Yeah,
the same?
Actually, of course, debug version is a lot slower than the debug version you are used to on Android or iOS, because everything you are doing in debug mode is your native bridge is listening on a WebSocket for any change you might make in your file. So every time you change anything in your JavaScript file, it's rebuilt in the background. So yeah, it is a lot slower on the development side, but if you build your native release version, it's pretty the same. There's no difference with.
Okay, thank you. The same question about build time. Is it the same or greater?
So I haven't shown this here. So it depends on how many native parts you have. So if you have, like, for example, Facebook SDK, Firebase, let's say, and then a few others. So yeah, it builds well. Okay, so it builds as long as it would build if you, for example, had to build the same libraries without React Native. However, this business logic is built in like 10 seconds, maybe less. So. Okay,
and the last question. You use pure JavaScript or some statically typed frontend?
Currently, my team is using FlowType. FlowType is shipped with React Native, so that's why we picked it. So we didn't want to add an additional dependency to our tech stack.
Didn't consider TypeScript?
Yeah. Actually, a lot of our libraries are written in TypeScript. But yeah, this was shipped with React Native. So we have developers which are fluent in TypeScript and FlowType. So TypeScript is even more popular. So yeah.
Thank you.
Maybe a little dumb practical question. What IDE is best to use to develop React Native?
Personally, I am using Visual Studio Code.
Okay.
And Xcode and Android Studio, because sometimes you have to like open your, for example, you have to configure your provisioning, your entitlements, and so on. So this is still on the native part. So those systems are still separate.
Mm-hmm. And another question, did you face any kind of really major and disruptive issues in React Native? For example, a couple of months ago when I experimented with React Native, I faced that it's almost impossible to make React Native fetch follow redirects on the custom redirect scheme.
Okay, so I didn't have problems with fetch, but you have to face this a weird JavaScript community custom that everything is changing like all of the time. So as I said yesterday, for example, between versions 0.46.2 and .3, the difference was that .2 didn't work at all. So yeah, that's and yeah, you have to accept it. Yeah.
Kind of zen. Thank you.
And thanks to the presentation. And what about this JS VM? Like you said that everything is running in the background, but is there only one thread? Like, I mean, could I do the same, do two parallel requests at the same time? Like I wanna, I don't know, fetch some user data, and at the same time I wanna some news which are not somehow related to that user.
Yeah, actually you can in ECMAScript, which is like a standard of JavaScript from a few years ago now. Yeah, so you can control the flow of your code using async await. So you can actually execute few tasks asynchronously. And yeah, you just like in Rx, you just call you just execute your promises because every method returns a promise, which is like a.
Yeah, I get it. I mean that for that promises we have only one thread, like common, I don't know, thread pool with one thread only. Yeah. Okay.
Yeah,
so, thank you.
Do we have any complex models to operate with concurrency? For example, on the all mobile platforms, we have something more complex than generic thread pool, something like an separation iOS to scheduling to some dependencies between synchronous tasks. Do we have something like that in React Native, or it should be kind of a bridge written?
Well, personally, I couldn't say because we didn't face such a problem. So yeah, probably there is, but I am not aware of such a solution.
Your own perception, is React Native suitable for application with a really solid business logic part, with some hardware communication with some third-party vendors?
Yeah, because if for some reason you can't achieve something on React Native on the JavaScript side, you just write your separate piece of code for this logic, which is like specific for the platform. So yeah. And you have to write tests and so on. So all those patterns you've heard about during those last 2 days, everything is something you can use here as well.
Okay, thanks.
Yeah.
So yeah, okay, guys. I think that we have to finish because it's lunchtime. I think that everybody is hungry. So yeah, let's for the